sisters, welcome back to my physics channel. Hi, how are ya? So today we're going to be discussing a new topic on this channel, and it's basically regarding the questions on how do instruments create sound, how do we hear music, or how do we even hear each other? And it all corresponds with one simple topic, and it is sound waves. So let's talk about that.
So in order to learn about sound waves, you basically need to know what a basic sound wave is. So a sound wave is a wave of compression and rarefication by which sound is propagated in a medium. Now, we need to understand what compression is since it is in the definition of a sound wave. So compression is basically a point of minimum spacing between particles of a medium for longitudinal waves. We also are going to need to know what a medium is. And it's really a simple definition for this. It's basically any substance that carries the wave. So it could be like water or air or anything that carries any wave. So here drawn is what a wave would look like if it's graphed. So from crest to crest, or one top of the wave to the second top of the wave, it is wavelength, and here drawn is the amplitude. So an amplitude is the max displacement from equilibrium, and the wavelength is how far the initial pulse went after completing one cycle. There are two different waves when talking about waves. There's a transverse wave and there is a longitudinal wave. So we need to talk about both of these to understand more about waves. So the definition of a transverse wave is that it's a wave that is perpendicular to the direction of wave travel. And now for a longitudinal wave, it's a wave that vibrates back and forth in the same direction of the traveling wave. So for a string instrument, it contains longitudinal waves, and basically the oscillating air by your ear has kinetic energy, which transfers the energy or the sound into the ear. Now, you may wonder, what is an oscillation though? Well, an oscillation is the movement back and forth on the string. So for a string, when you want to find the period or the frequency, the period equation is 2 pi square root of the mass divided by the spring constant. And frequency is basically just the reciprocal of that. Now, what is period? Well, period is the number of seconds it takes per oscillation. And frequency is the number of oscillations per second. Well, you also, if you need to find wavelength, you could always just do the velocity divided by the frequency, and that will give you wavelength. Tension plays an important role with the velocity on the string. So if you tighten the string or basically increase the tension, it also increases the velocity. But if you loosen the string or if you basically decrease the tension, this will also decrease the velocity. The reason that when you tighten the string or increase the tension, it increases the velocity is because the linear density is unchanged. So the difference between a violin string or a cello string is the thickness of the strings. So it is said that the thicker the string, there's an increase of linear density. And the equation for linear density is shown below. In order to find the velocity of a string, it's going to be the square root of the tension divided by the linear density, which is going to be the mass divided by length. Also, in order to find the wavelength pattern, it's going to be 2L divided by N.
The whole entire video, let's take a moment to recap what we learned about the sound that we hear coming from instruments, specifically the violin. So basically the sound wave is produced by the vibrating object, and in this case it would be the vibrating springs on the violin. So as the string vibrates on the violin, it sets surrounding air molecules into vibrational motion paths, and there is an alternating of compressions on the string and expansions on the string, and this basically makes the sound wave that we hear through our ears. So the pressure of wave consists of compressions and refractions, and the compression is when there's high pressure and air molecules are compressed into small region places, and the opposite would be a rarefaction or an expansion, and this is where there's low pressure and air molecules are spread apart from each other. So I hope you enjoyed learning about wavelengths and different sound waves and the reason why an instrument actually makes a sound and not that it's magical. Thank you, and see you later on my channel.